let's look at the first problem of today, problem 22. On June 1st, a group of students are standing in rows, with 15 students in each row. On June 2nd, the same group is standing with all students in one long row. On June 3rd, the same group is standing with just one student in each row. On June 4th, the same group is standing with 6 students in each row. This process continues through June 12th, with a different number of students per row each weekend, or each day, sorry. However, on June 13th, they cannot find a new way of organizing the students. What is the smallest possible number of students in the group? So how will we approach this problem? So let's first say that our number, mystery number m, that's the smallest possible number of students in this group, is equal to 15n. Because on June 1st, we have a group of students sitting in rows, 15 students in each row, so that means that m, the number of the least amount of students possible, is divisible by 15. Likewise, it's also divisible by 6. We know that from June 4th. It's also equal to like 6a. All right, so that's what we have so far. We also know that on June 1st to June 12th, there are 12 different unique ways of organizing the students. However, on June 13th, they can no longer find a new unique way of organizing the students. Okay, so what does that tell us about M? And although I'm sure that Elmo, Kylo, or whatever, and Bill Nye are all riveting subjects, let's first focus on the smallest amount of students possible in one group. Right, so 12 factors. And what do we know about how to prime factor a number? So if there are 12 number of factors, and we know that 12 could be equal to 3 times 4, 3 times 2 times 2. It could also be equal to like 6 times 2, so on and so forth, right? And since it has 12 total factors, then that means the smallest possible value would be something like 2 squared times 3 times like 5. But that's not necessarily the case, right? So let's see. If we have 12 factors, then that means the smallest number of, or like the smallest possible value for m would be if you take 2 squared times 3 times 5. Because since 12 is equal to, we can write it as 3 times 2 times 2 times 2. Then if we have 3 prime factors, all called a, b, and c, then a to the a squared times b times c is equal to m. Substituting in 2, 3, and 5 for a, b, and c respectively, we can get that the smallest possible value of m is 2 squared times 3 times 5, 4 times 15, that gives us 60. Now, we just have to perform one last check. Is 60 indeed divisible by 15? Yes, it is. 60 is equal to 4 times 15. 60 is also equal to 6 times 10. So then, the smallest possible value for m is indeed equal to 60. Does that make sense? Right, so the reason why I got 5, or like how I got 5 from here, is that we know that there are 12 total factors. And if, let's say we have a number a is equal to p1. Wait, no, sorry. Let's just say we have a number like m, right? A is equal to p1 to the a1 times p2 to the a2 times p3 to the a3, so on and so forth, all the way to pn to the a sub n. So basically, if we have a number that can be expressed like this, where p is a prime number, for example, m is like some number like, I don't know, 270. 270 is equal to like 2 to the 1 times 3 cubed times like 5 to the 1, right? So in that case, P1 equals 2, P2 equals 3, P3 equals 5. A1 equals 1, A2 equals 3, A3 equals 5. A3 equals 1, sorry about that. It's not equal to 5. So if we can write it like that, then that means that how many factors are there of m? That would be A1 plus 1 times A2 plus 1 times A3 plus 1, so on and so forth. Multiply like A4 plus 1, A5 plus 1, AN minus 1 plus 1, and then all the way to AN plus 1. So that's how you find the number of factors. So if we're given that this product is equal to 12, then we want to find like different ways of factoring 12. We find that if we factor as 3 times 3 times 3, 3 times 2 times 2, then we get that a squared times b times c is equal to like m, where m is like the least number of students possible. Because 2 plus 1 equals 3, 1 plus 1 equals 2, 1 plus 1 equals 2, 2 equals a1, 1 equals, let me just write 1 right here and 1 right here, 1 equals a2, 1 equals a3. So then substituting in 2 for a, 3 for 5, 5 for c, 3 for b, 5 for c. Yeah. Basically what we're doing is just substituting in the smallest prime numbers for a, b, and c, and that's how we get 5. We also know it has to be divisible by 5 because we're given that m is like a multiple of 15 in the problem. It says that you can split m number of students into like 15 different groups. All right. So that was the first problem for the day. That was like a warm-up on factoring. So now let's look at problem 23. So Tom has 12 slips of paper, which he wants to put into 5 cups labeled A, B, C, D, and E. He wants the sum of the numbers on each slip to be an integer. Furthermore, he wants 5 integers to be consecutive and increasing from A to E. The numbers on the papers are 2, 2, 2, 2.5, 2.5, 3, 3, 3, 3, 3, 3.5, 4, and 4.5. If a slip with 2 goes into cup E and a slip with 3 goes into cup B, then the slip of 3.5 must go into what cup? Okay, so let's draw 5 cups, shall we? So here's cup A, cup B, cup C, cup D, and cup E. A, B, C, D, and E. Now we know that 2 goes into here and 3 goes into here. Now, in order for 3.5 plus some number to be equal to an integer, then we know that 3.5 must add to some number that has like 0.5 added in its decimal place. Basically, like 3.5 plus 2.5 will give us an integer 6. So that's what we want, right? We also know that the 5 integers are going to be increasing. So let's do something first. Let's sum up all these 12 numbers. So we have 3 2s, that would give us 6, plus 5, 2.5, so that would give us 5, plus 4 3s, that would give us 12, plus 3.5, plus 4, plus 4.5. So if we sum that all up, we get 35. And we know that since A, B, C, D, and E are all positive integers, and that these 5 integers are consecutive and increasing, then that means that if we can split 35 up into 5 increasing consecutive integers, then we can basically find out what's A, what's B, what's C, what's D, what's E. So first of all, let's divide 35 by 5. We get 7. So then let's say that 7 is a middle cup. So then B must be 6, A must be 5, D must be 8, and E must be 9. Consecutive means that they're all like they're all arranged such that the next term is like one more or one less than the previous term. And since they're increasing, we know that each term must be one greater than the previous term. So we can indeed verify that 5 plus 6 plus 7 plus 8 plus 9 is equal to 35. So what does this tell us? This tells us that in order for like cup B to have a sum of 3, now let me change my colors, then the other slip in cup B must also be 3, because 3 plus 3 equals 6. If like a number like 2 was in cup B, then we would have to add another slip labeled 1, but we don't have a slip labeled 1. So the only option for cup B is to have another slip labeled 2. So let me first cross off a couple things. So we already used one slip that's labeled 2. We used two slips that's labeled, sorry about that. Two slips that are labeled 3. All right, and now let's look at E. 2 plus 7 is equal to 9. So how do we get a number to be equal to 7 in our case? Well, we have a couple choices. We know that 3 plus 4 is equal to 7, and 2.5 and 4.5, if you add those two numbers up, is also equal to 7. So let's first consider the case where we have 3 and 4 here. All right. So then if we have 3 and 4 here, let me cross off another 2, let me cross off another 3. Now let's look at cup A. So we know that cup A must also have 2, must be either 2.5 and 2.5 or 2 and 3. Let's look at cup C. We know that cup C must be 3 and 4, or like, and that's, or 2.5 and 4.5. Oh, and we should also cross. And what about cup D? Cup D, the sum is equal to 8. So how can we get a sum equal to 8 using the numbers 2, 2.5, 3, 3.5, and 4.5? Well, if we were to directly add up two numbers, we would get 3.5 and 4.5. Is there any other way to get some numbers to be equal to 8? Well, sure, we can get like 2 and 3 and 3. However, in our case, we've already used up like all the 3's except for 1, so we can only use 1, 3 in our case. So let's look at this. Now let's just do 4.5 and 3.5. So 4.5 is here and 3.5 is here. Now let's cross off 3.5 and 4.5. Now did you just see what we did? The 3.5 must go in cup D. However, is this necessarily true? Let's see if the rest of the numbers work out. So 2 and 3 go here. That's for sure. And what about cup C? So we can put 2.5 and 2.5 here, right? And then we also have another 2. So 2.5, 2.5, and 2. So this all works out. So indeed, 3.5 must go in cup D. Does that make sense? Yeah, if you have any questions, please ask. If you don't want other people to see if you ask a question, you could always try to message me. All right, since no one's asking, I'll assume that my explanation was clear, and let's move on to problem 15. What is the largest power of 2 that is a divisor of 13 to the 4 minus 11 to the 4? Huh? but there are 4 3s. I mean, like, if you look at this, right? Let me just zoom in for a moment and like get rid of all this, right? Okay, so let's count. So we have 3 2s. That's 3 numbers. 2.5. Well, 2.5s, that's 5 numbers. And then 1, 2, 3, 4. That's 4 3s. That's 9 numbers in total. Then we have 3.5, 4, and 4.5. That's also 3 numbers. So 9 plus 3, that's 12. There are like 3 3s. Sorry, 4 3s. If you look at the last number, that's 3.5. There's actually like 4 3s and then like a 3.5. I'm using Microsoft Edge, if you're confused, but like there are 4 3s. But yeah, it's understandable if you get confused with like the last 3.5 since this is kind of small. Yeah, right. So let's look back at problem 15. So we have 13 to the 4 minus 11 to the 4. So I'm sure most of y'all know what difference of squares is. Basically, if we have a squared minus b squared, then we can write this as a minus b times a plus b. If you want to check if this is valid, then you could just like distribute this out, right? A squared minus ab, well, sorry, a squared plus ab minus plus minus b squared. So then cancel out the ab and minus ab, then you get a squared minus b squared. So basically, we can use difference of squares to rewrite our expression 13 to the 4 minus 11 to the 4. So let's say that a is equal to 13 squared. So then we have 13 squared minus 11 squared. So then this gives us 13 squared minus 11 squared times 13 squared plus 11 squared is equal to our expression 13 to the 4 minus 11 to the 4. Continuing on, we have 13 squared minus 11 squared. Let's use difference of squares once again. 13 minus 11 times 13 plus 11 times 13 squared plus 11 squared. We know that 13 minus 11 is equal to 2. 13 plus 11 is equal to 24. So, but what's 13 squared plus 11 squared? Well, 13 squared is equal to 169. 11 squared is equal, 169. 11 squared is equal to 121. So if we add those two up, we get 290. I recommend you memorizing all the squares from like 1 to 30. Those are like the ones that you should memorize because those are mostly the ones that you'll use. Otherwise, if you need to use something like 41 squared, you could always just use FOIL or life or whatever it's called. So let's look at this expression. So we can factor out a 2 right here. There's a 2 right here. What about 24? 24 is equal to 2 cubed times 3. So we can factor out a 2 cubed here. What about 290? 290 is equal to 2 times 145, so we can factor out a 2 here. So what do we get? We get 2 times 2 cubed times 2, that's equal to 2 to the 5th. So in conclusion, the largest factor of 2 would be 30. Large power of 2 would be 2 to the 5th, otherwise known as 32. Does that make sense? Yeah. Does this make sense how I broke 13 to the 4 minus 11 to the 4th as 13 squared and 11 squared and then like further broke it down? Yeah, sure. I can scroll down a bit. You want to see the rest of my work? Right. So I'm assuming you're either like taking a couple notes. So in the meanwhile, I'll talk a little bit about problem 20. So problem 20 is about the LCM of A and B, and we know that that LCM is equal to 12. And the LCM of B and C is 15. What is the least possible value for the LCM of A and C? All right, can I make the screen a little larger? You mean like scroll in? Yeah, sure. I can't really make the screen or like my Zoom share screen a bit larger. I think if you like double click on the Zoom interface on your end, you could you get full screen zoom, right? Yeah, so let's continue looking at problem 20. So we know that the LCM of A and B is equal to 12, and the LCM of B and C is equal to 15. By the way, this is a comma, not another C. Let me just rewrite this as a comma. Is equal to 15. Right. So it looks like some of y'all have gotten an answer already. So let's check. So we know that the LCM of A and B is 12. And we know that the LCM of B and C is 15. So what's common between 12 and 15? Well, the common factor would be 3. So that means that B is equal to like the multiple of 3 something, like 3n. It doesn't matter what n is. Well, it kind of does matter, right? And we also know that B has to be less than 12 because that's the LCM. If like B is greater than 12, then that wouldn't be the LCM. So we also know that B cannot be a multiple of 2, right? Because if B is a multiple of 2, like say B is equal to 6, then that means that the LCM of B and C also must have a multiple of, must also have like be a multiple of 2. However, 15 is odd, so B must be 3. I mean, B could be 9, I guess, but like that. Well, B could be 3 or 9 since n could always be odd. All right, anyways, moving on. We know that A has to be even because if B is odd, then where does the factor of 4 come in? So A is equal to like 4 something, 4 n basically. Could be 4, it could be 8, it could be 12 for all we know. And now let's look at the LCM of, or like what C is equal to. C is equal to 5 something. And the smallest possible value for A is 4, the smallest possible value for C is 5. So then the LCM of 4 and 5 is 20, right? Yeah, and also 9 can be like the else can be B also can't be 9, right? Because if B is equal to 9, then 12 then the LCM of A and B has to be a multiple of 9. Likewise, the LCM of B and C would also have to be a multiple of 9. So the only possible value for B is 3. And then A also has to be 4, C also has to be 5. So then these are the only possible values of A, B, and C. Wait, why can't C be 15? Well, it could, right? But since we're considering what is the least possible value for the LCM of A and C, then in order to find the least possible value for the LCM, then A and C should be as small as possible. The smallest possible value for C is 5, the smallest possible value for A is 4. Not really. I mean, I guess you could use brackets or parentheses. The format doesn't matter too much unless you're writing a formal proof. So does anyone have any questions over like how I did this? All right, okay, so let's look at problem 24. Since it looks like no one has any questions about the previous problem. All right, so, do you have a question? Okay, I'll assume that you meant yes, as in you have no questions then. The digits 1, 2, 3, 4, and 5 are each used once to write a 5-digit number PQRST. The 3-digit number PQR is divisible by 4, and the 3-digit number QRS is divisible by 5. And the 3-digit number RST is divisible by 3. What is P? Okay, so let's start with a few key things. So we know that in order for QRS to be divisible by 5, then S must either be 0 or 5, every multiple of 5 ends in 0 or 5. However, since the digit 0 isn't allowed to be used to write PQRST, then S must be equal to 5. Good job, Getty. Yeah, we often start with the obvious when doing a problem. We also know for a 3-digit number PQR to be divisible by 4, then that means that number 1 R ends in an even number, so that would be 2 or 4. And we also know that QR must be divisible by 4. If we have any number that's divisible by 4, only the tens and units digit matter really. Q and R have to be divisible by 4. So what could Q and R be? Q and R could be equal to 12, 24, 32, and well, that's it really. 42 can't work. So what about RST? In order for RST to be divisible by 3, then that means that R plus S plus T is divisible by 3. So then that means that it's equal to 0 mod 3. We know S is equal to 5. So we can rewrite S as 5. And since I actually wrote this. This should be PQ, by the way. Sorry about that. When I wrote this, I meant well, yeah, it is QR. Why would I say? Okay, yeah, it's QR. Okay, yeah. Sorry, I didn't make a mistake. Okay, so we know that S is divisible by 5, and we know that R is either 2 or 4. And so then what does that make of T? So then what are the multiples of 5 that are bigger than, what are the multiples of 3 that are bigger than 5? That would give us 6. 6 can't work because R is at least 2, so 7 at least. So then we have 9, right? If R is equal to 2, then that means that T is also equal to 2. That can't work, right? R and T can't both be equal to 2. So then let's look at 12. Then in that case, if R is equal to 2, then T is also equal to 5. That can't work, right? S and T cannot both be equal to 5 via the given. So then R must be equal to 4. If R is equal to 4 and 5, and we have S is equal to 5, then we have 4 plus 5, that's 9, plus T then equals 3. So R equals 4 and T equals 3. And we also know that in that case, Q is equal to 2. So you have 2, 4, S is equal to 5, and 3. And now we have to determine what P is equal to. P is equal to 1.
Wait, but there are other answers.
What do you mean by other answers?
I don't know. How about 3, 1, 2, 5, 4?
3, 1, 2, 5.
Oh, never mind. The RST isn't divisible by 3.
Yeah, in that case, 2 plus 5, that would give us 7 plus 4, 11. Yeah. So then 1, 2, 4, 1, 2, 4, 5, 3. Does that make sense? How I got here? I could repeat it. I could repeat my process if you want, since it seems like many people were caring more about CDC. Okay, sure, yeah, of course. So first, we start with the obvious. What is S equal to? We know that QRS is divisible by 5. That means that S must either be 0 or 5, since every multiple of 5 ends in 0 or 5. However, we know that S cannot be equal to 0, since we're only given 1, 2, 3, 4, and 5 to play with. So S equals 5. All right, now let's consider PQR. Well, we know that QR must be a 2-digit number that's divisible by 4. P can be whatever it wants, but as long as QR is divisible by 4, then that means that PQR as a 3-digit number is divisible by 4. So using QR, what are the remaining multiples of 4 we can construct? Well, 12, 24, and 32. You might say, what about 52? We already used 5 to be equal to S. We cannot use multiple 5s, so Q cannot be equal to 5, so 34. So 52 does not work. All right, so now let's consider R as T. R plus S plus T is a multiple of 3. That means that it's 0 mod 3. That's how we would write this using mods, since we're using number theory right now. Okay, so we know that S is divisible, or S is equal to 5, right? So we can replace S as 5. So what are R and T equal to? Well, we know that R is either equal to 2 or 4. So since the smallest possible value for R is 2, then that means that the multiple of 3 that R plus S plus T is equal to is at least equal to like 9, since like 9 is a smallest multiple of 3 that's bigger than 7. So let's consider 9 for a moment. R equals 2, S equals 5, T in that case would also have to be equal to 2. R can't be 1 since we're given that PQR is divisible by 4. If R ends in 1, that means that we have some number that's odd, right? And odd numbers can't be divisible by 4. So 9 does not work. What's the next smallest value? What's the next smallest multiple of 3? That would be 12. So let's consider R equals 2 for that case. R equals 2 plus 5, that would give us 7 plus T is equal to 12. That means that T is equal to 5. Yeah. Since T is equal to 5, then, well, that would work. That couldn't work, right? Because S is equal to 5 and T cannot also be equal to 5. We're only given, R and T can be the same number. We're given that in like the first part of the digits are used once each. Yeah, 12 can be divisible by 3. That's the point, right? That's why I'm using like 12 as a possible multiple. So if R cannot be 2, then let's consider R equals 4 and like R plus S plus T equals 12. So we're still in the 12 case. So R equals 4, 4 plus 5, that's 9. 9 plus T equals 12, that means that T equals 3. That works, right? Yeah, yes, it works. That's the point, right? But is 12 necessary, or is T equals 3, R equals 4 necessarily the only case that works? Let's consider for a moment 15. 15 is equal to 5 plus 5 plus 5. That cannot work. R cannot be 5, T cannot be 5 as well, since S is already equal to 5. So 12 is the only multiple of 3 that could give us a working QRST, PQRST really. So R is equal to 4, Q is equal to 2, and T equals 3. So we have essentially 2, 4, 5, 3. And now we want to find what P is equal to. The only remaining number is 1, so P equals 1. So that's how we get 1. Does that make sense? Okay, all right. Let's look at problem 17 then. Starting with some gold coins and some empty treasure chests, I tried to put 9 gold coins in each treasure chest, but that left 2 treasure chests empty. So instead I put 6 gold coins in each treasure chest. Then I had 3. Oh sure, you can look at the next one again. Essentially the digits 1, 2, 3, 4, 5 are each used once to create the 5-digit number PQRST. 3-digit number PQR divided by 4, 3-digit number QRS is divided by 5. 3-digit number RST is divided by 3. What is P? Okay, so let's look back at problem 17. So I have like M gold coins. I'm rich, right? I'm rich, right? I have like M gold coins. That's a lot of gold coins. And some empty treasure chests to fill for my beloved students so I can give away these treasure chests to my beloved AMC8 students, right? So now I tried to put 9 gold coins in each treasure chest because I was being extra generous, but that leaves 2 treasure chests empty. So what does that tell us? Well, that tells us that M, that's the number of gold coins I have, is divisible by 9. Right. But if I instead put 6 gold coins in the treasure chest, then I have 3 gold coins left over. How many gold coins do I have? So let's say I have M gold coins in like N treasure chests. So we know that M is like some multiple of 9. So that means that M is like 0 mod 9. And we also know that if I try to put 6 gold coins in each treasure chest, that would be 6N. 6N plus 3 is equal to M. So how many gold coins do I have? So what does this tell us? This tells us that M is equal to 0 mod 9. So let's substitute in 6N plus 3. So that means that 6N plus 3 is equivalent to 0 mod 9. Let's subtract 3 from both sides. We get 6N is equivalent to negative 3. That's equivalent to 6 mod 9. So 6N is equivalent to 6 mod 9. So let's divide both sides by 1 by 6. So N is equivalent to 1 mod 9. So what does this tell us? Yeah, N equals 10, right? So if N is equal to 10, then we get that M is equal to 60 plus 3, that's equal to 63. So you notice some of y'all saying that 45 works, and on the paper it looks great, right? M equals 45. 45 is equal to 42 plus 3, so that gives us N equals 7. However, if M is equal to 45, then it can't really work, right? Because first of all, we know that if I try to put N gold coins in each treasure chest, that's 2 treasure chests left empty. And that can't work, right? So then we get D. Okay, yeah, so 45 apparently works. So let me, wait, give me one moment. So I actually used a fairly dumb solution to do this. First of all, we can actually just use system of equations. Yeah, 63 does not work. Let me just, after class, I'll figure out why 63 or like why modular arithmetic did not work, and then I'll post something in our Google Classroom. But first, let me do this using system of equations. Okay, yeah. So then I put 6 gold coins in each treasure chest plus 3. So then m is equal to, so well, we can set these to equal to each other. So we have 9n minus 18 is equal to 6n plus 3. So 3n is equal to 21, so then n equals 7. That's a far easier way to do this. I was being really dumb about this. Okay. So then if n is equal to 7, then we have, well, m equals 45, 9 times like 5. Yeah, so 45 is indeed the answer. Sorry about that. So the easiest method is just using system of equations. I'll figure out why the modular arithmetic that I did didn't work out. Oh, okay. So basically m is equal to like 9 times n minus n amount of treasure chest minus 2. So then if we distribute the 9, right? 9 times n times 9 times negative 2, that gives us 9n minus 18. And then we can set that equal to 6n plus 3. So then there's our far simpler, more elegant solution using system of equations. So let's look at problem 19. For any positive integer m, the notation m factorial denotes the product. Oh, by the way, do you have any questions about this problem? Okay, so 4秒钟 then. So let's look at problem 19. For any positive integer m, the notation m factorial denotes the product of the integers 1 through m. What is the largest integer n for which 5 to the n is a factor of the sum 98 factorial plus 99 factorial plus 100 factorial? All right, so this is one fantastic expression. 98 factorial plus 99 factorial plus 100 factorial is really big. First of all, so let's rewrite this as something else. 99 factorial is equal to 98 factorial
times 99.
99. Likewise, 100 factorial is equal to 98 factorial times 99 times 100. So let's rewrite this expression. So let's factor out the 98 factorial. 98 factorial times 1 plus 99 plus 99 times 100. Okay. So then what is the large factor of n for which 5 to the n is a factor of the sum? So first let's find what this part. Let me change colors actually to like blue right now. So let's find how many factors of like 5 can be divided here. What's 1 plus 99 plus 99 times 100? So then we basically get 100 plus 99 times 100. So that gives us 100 squared, basically. So this 100 squared, we can rewrite this as 2 to the 4th times 5 to the 4th. So then we know that 5 to the 4th is like, well, the biggest power of 5 that divides the right-hand expression. So what about 98 factorial? Let me switch another color for that in red. So 98 factorial is equal to 1, 2, 3, 4 times 5 times 6, 7, 8 times 9 times 10 times 15 times some numbers 15 times 20 times 25 times 30 times 35 times 40, basically every factor or every multiple of 5 that's less than 98 is equal to like some numbers that are not a factor of 5 times 10 times 15 times 20 times 25 times 30 all the way to 95. So one way we could find how many, like what's the largest power of 5 that divides 98 factorial is by just adding up the exponents of all these numbers, like 1 plus 2 plus 1 plus 1 plus 1 plus 1 plus 1 plus 1 plus 2 plus like so on and so forth, right? But that's not a really efficient way to do this. Instead, what we can do is take 98 divided by 5. That gives us 19. What's 19 divided by 5? That's equal to 3. So in conclusion, it's 21. So what's 21 plus 4? That would give us C as our answer. So does anyone understand what I just did, especially for like the 98 factorial part? Basically, what I was trying to do is like count the number of multiples of 5 that's less than 98. So there are 19 of those, right? And then count the multiples of 25 that's less than 98, because like 25 is equal to 5 squared. So that means that it would add 2 to the like greatest power of 5 that divides 98 factorial instead of just 1 like the other 5s. So then we just take like 19 plus 3, that's equal to 21. 21 plus 4 is equal to 25. Does that make sense? Oh, why add 4? Because in the right hand part, right? We get 1 plus 99 plus 99 times 100, that's equal to 100 squared. 100 squared is equal to 2 to the 4th times 5 to the 4th. Wow. And then it turns out I can't do basic addition anymore. Okay, this is a very sad situation. The answer is actually D. 19 plus 3 is equal to 22, not equal to 21. So then in conclusion, we get 22 plus 4 is equal to 26. But why are there 4 5s in the 100? Because we get 100 squared. And since we have like 2 5s instead of 100, then we get like 2 times 2, that's 4. 100 squared is equal to 2 to the 4th times 5 to the 4th. That's basically what I'm saying. Okay, so does anyone have any questions for this? By the way, the answer is 26. It's actually equal to 19 plus 3, which is equal to 22, not 21, plus 4. All right, sure. So we have a positive integer m with a notation m factorial. That's basically factorial, right? 1 times 2 times 3 is all the way to m. M factorial basically means that the product of all integers between 1 to m inclusive. What is the largest integer n for which 5 to the n is a factor of 98 factorial plus 99 factorial plus 100 factorial? So what I did is rewrite 99 factorial as 98 factorial times 99. And I rewrote 100 factorial as 98 factorial times 99 times 100. So I factored out the 98 factorial in this expression and rewrote it as 98 factorial times 1 plus 99 times 100. So let me just like rewrite this, right? So this would just give us 98 factorial times 100 squared. And we want to find what is n such that 5 to the n is a divisor, or like is a divisor of 98 factorial times 100 squared. So this is 100. So you can rewrite this as 98 factorial times 100 squared is equal to like 9n, sorry, not n to the 5, other way around, 5 to the n times like some other number we don't really care about. 5 to the n is basically the largest possible power of 5 that's still a divisor of 98 factorial times 100 squared. And basically what we do is say that 98 factorial is equal to like 5 to the 22 times some number we don't really care about, and 100 squared is 5 to the 4th times some number we don't really care about. So then in conclusion, n is equal to 26. Oh, does that make sense? Yeah, carelessness gets even the best of us sometimes. Yeah. So if no one has any questions, let's look at problem 24. Mrs. Sanders has 3 grandchildren who call her all regularly. One calls her every 3 days, one calls her every 4 days, and one calls her every 5 days. It's very clear to see who's the favorite grandchild. All 3 called her on December 31st, 2016. On how many days during the next year did she not receive a phone call from any of her grandchildren? Okay, so Miss Sanders is very resentful of her grandchildren who do not in fact call her every day. So she's counting the number of days in which she receives no love from any of her 3 grandchildren. So let's look at 2017. It's not a leap year. So how many days are in 2017? Could anyone put that in chat? Right, 365. Since it's not a leap year, we have 365 days. And of these 365 days, one of her grandchildren calls her every other 3 days, one of her grandchildren calls her every other 4 days, and one calls her every other 5 days. So since this is like on our last stretches of today's class, I actually want to see if y'all can get a solution to this problem. So let me actually give you like 2 or like 1 or 2 minutes to solve this problem. So it looks like most people have gotten this. So I'll give you like 30 more seconds to do this and then we'll talk. Okay, so it looks like everyone, or like most everyone, agrees that it's equal to E. So let's see. Miss Sanders has 3 grandchildren. They call her all very regularly. So every 3 days, she receives one from the first grandchild. So what's 365 divided by 3? That's approximately equal to 121. So on 121 days of this year, she receives a call from her first grandchild. So what's 365 divided by 4? So that would be equal to, roughly equal to 91. And then we subtract 365 divided by 5, that's equal to 73. The reason why we do this is we're subtracting the number of days in which Mrs. Sanders does indeed get a phone call from her grandchildren. So you might be like, yay, 365 minus 121 minus 91 minus 73, that's equal to 78. However, alpha 360 is right, good job. So indeed we have to consider the principle of inclusion and exclusion, meaning, what if on every 12 days her first grandchild and her second grandchild call, right? Because 12 is a multiple of 3 and 4, so like naturally, every 12 days their call would overlap. So we have to add back 365 divided by 12. What's 365 divided by 12? You get 30, right? And then we also have to add back the days in which her first grandchild and her third grandchild call together. That would be 3 times 15. So 365 divided by 15, what's that equal to? 24. Similarly, we have to do 365 divided by what's 4 times 5? Her second grandchild and her third grandchild will call her both on every 20 days. So we have to add back 18. And you might be like, yay, we're done, right? But not quite. Because you see, every 3 times 4 times 5 days, all 3 grandchildren call at the same time. So in fact, we have to divide, or we have to subtract 6 from this again. So if we were to do this, right, 365 minus 121 minus 91 minus 73 plus 30 plus 24 plus 18 minus 6, if we were to do all that, then what would our answer be? It would in fact be equal to 146. The reason why it's not 152 is because I think y'all included basically y'all forgot to re-subtract the days in which all 3 grandchildren call, right? So let's draw a Venn diagram. Okay, and then let's draw like a graph around this. So what we're trying to do is basically find the area of the rectangle that's not basically find the number of days where grandchildren don't call. Basically like the stuff outside of the Venn diagram. The stuff inside of the Venn diagram is like the number of days first grandchild calls, second grandchild calls, third grandchild calls. So what we do is we subtract this, and we subtract this, but we over subtracted the parts like that are right here. So we add like this stuff back in. So we add this, we add this, we add this. But then we like added like the part in the middle too many times. So we have to subtract it again. So like we subtract the 6 at the end. So that's why I think everyone got 152. Like, does that make sense? No, the reason why it's not minus 12, like why you're not subtracting 6 2 times, is because think about it like this. So we double counted the number of times, or like we double subtracted the number of times where 2 grandchildren call on the same day. So we add those days back, right? But then we forgot to subtract, or like if we add those days back, then we add back all the days in which all 3 grandchildren call. So like we only need to subtract 6 once, if that makes sense. All right, so that will be the last problem of today's class. So, see you all next week then. Next week we'll be going over the wonderful topic of geometry, and you all will be witnessing my amazing ability to draw very accurate geometric diagrams. All right, see you all next week then. Take care. Bye.
Bye.
Thank you. Bye.
Bye.